So in today's session, we are going to discuss about the support vector machines and also the decision trees. Let me open up the SVM. I think I need a data set also. So we have the data set over here. Social network ads. Okay. Now let us understand this one. We already have done a couple of programs on this social networking ads data set. Okay. In the same way, if we are going to understand the same, see what happened, a company where it has done some sort of advertising and they have got certain data based upon their advertising. How many customers have reacted to their advertising? Out of the people who has reacted to the advertising, how many people have purchased the company's product? Okay, how many people have purchased the company's product? So if we want to do this sort of analysis over here, we need to understand age, estimated salary, and purchased or not. So finally, the target variable which is needs to be classified is whether the customers purchased the product or not. There are male customers and female customers who are associated with the age and the respective salary. Okay, who are associated with the age and the respective salary. So now let us try understanding this part. See, I have imported the NumPy and Matplotlib along with the pandas. And here I need to provide the valid. Here I need to provide with the valid path for this one. Now I wanted to run this data set. We need this consoles. So we have the data somewhere here. And now I'm going through the values. Y is going to be X value and Y value. Let us go ahead with the X value and Y value. So this is the X values being held by the age and the respective salary of each and every individual for a particular data set. And then executing the Y value, which is going to be a target variable. So we have split by importing the train test split, and test size is 25% and training size is 75%. Okay, this is how that we have segregated along. And now I just wanted to do the scaling. As I told you, a standard scaler, using the standard scaler, I'm trying to do the scaling part. Okay, I am trying to scale this part. done the scaling. What happened? X underscore train is not defined. Might be I have not executed this part. Now, let me execute this part. And now, I just wanted to use the SVM from where I will be having something called SVC. SVC is the function where we are trying to understand the linear support vector machine. Kernel is linear. So I'm trying to fit as a classifier dot fit x underscore train comma y underscore train. So the rest of the values other than kernel and the random underscore state, the rest of the values have been taken as a default values. And here I am executing, predicting the test set results. Okay, fine, done. See, based upon the classifier that you have ran across, you can always try understanding the classifier. Also, oh, I'm sorry. And now, let us go ahead and understand the matplotlib. So this is how the visualization that we come across. So this will quite looks almost similar to the logistic regression. Okay, more or less it acts something just like this, but it is going to be a little bit different from the logistic regression. In the logistic regression, it will try to act as a classifier in terms of a linear format. Of course, this is also a linear format where you can go ahead with the 3D planes of the data, X data, Y data, and Z data also. Okay, Z data represents like multiple predictors, of course, and also here different planes of or different vectors of the data can be represented in order to implement this SVM, support vector measures. Okay, the image or the visualizations almost something just looks like exactly as the logistic regression results. Okay, so this is how about the SVM. Let me open up the decision tree classification. So in the decision tree classification, generally we know that the decision trees always rely on root node and child node, parent and child. Okay, root node is the topmost node from where the classification will be done, and after that one, child node is the node which was segregated or more elaborated from the parent node. So now let us try executing the same set of stuff. So let me just go ahead with we have something called decision tree classifier. Decision tree classifier in scikit-learn will make us to understand more about the decision tree classification. Okay. So now let us see. While we are understanding about this decision tree classification, we should understand something called entropy, and we should also require to understand something called a Gini index. Okay, likewise we have some other concepts, okay, where I will just elaborate this decision tree with the respective ways of understanding the decision tree along with the random forest in the tomorrow session. Okay, but before that one, we have to first execute this part, and we need to understand that this the import where we are doing it is a decision tree classifier. Okay, that is a function that we are trying to use here by giving the entropy as a criterion. Okay, I will tell you why it is entropy. Do we have any other criterions? Yes, we do have any other, even other criterions also apart from the entropy, but we need to understand what exactly the entropy and the Gini index, okay, kind of stuff. So this is the confusion matrix that you can make across, and let me just publish the results of this confusion matrix. Can anyone let me know the accuracy of this model? Can anyone please calculate and let me know the accuracy of this model? Anusha, Ashok, Kiran, Sunil, Suresh. What is the accuracy for this model? Something 91 divided by 100, which is almost 91 percentage, is the accuracy of this model from the which we can derive from the confusion matrix here. Okay, so now if you can take a look at this training results, this is how it is going to show you how exactly that we can classify the data. Okay, this is the classification which was done for this, and let us go ahead with the. Okay, so this is the kind of decision tree classification which has tried to given us based upon the data, whatever it was passed across, that may be a training data set or the test data set, and these are the results where we have got it through. Okay, and you can see the separation. It is not something just like a single level of a linear separation for the entire plane, and you can see the random separation it was observed clearly. Okay, by highlighting the wherever whatever it was led to make the product purchase by the number of different customers. Okay, all of you understand this concept? Any questions so far that whatever that we have discussed about the support vector machines and the decision tree classification? Tomorrow I will just go ahead in detail, and we will see the one more example of the decision tree classification along with the random forest, and we will be discussing about different forms of like entropy and Gini index in the decision tree classification, and how do we identify the different segments of the classifications within the decision tree and the random forest. Okay, okay guys, see you, we will meet again tomorrow. Thank you.